Okay, this is Mr. Peterson. We're going to be looking together at examples, model problems for worksheet 5.7, completing the square. Okay, on this first example, we've got 5 plus and minus 9 over 7, and we'll just treat those separately. 5 plus 9 over 7, and 5 minus 9 over 7. The first one gives 14 over 7, which is 2. And the second one simply gives negative 4 over 7. So your answers are 2 and negative 4/7. Okay, there's one extra step on the second problem here. We have to simplify the square root of 64, which is 8. So the first time through, you're going to use the plus sign. Square root of 64 is 8, so we're going to be adding that, and you get 16 over 2, which would be 8. And on the next one, you use the minus sign. 8 minus 8 over 2, which is 0 over 2. And you get a second answer of 0. Okay, square root of 28 on problem 3 gets broken up into a perfect square of 4 times 7. So we're going to go 6 plus and minus root 4 root 7. Sorry, root 4 root 7. And then that root 4 becomes 2. And that's as far as you can take this problem. There's actually two answers, the positive 2 root 7 and the 6 minus 2 root 7. Okay, on the next one we have to break up 48, and I've trained you to take 48 divided by x on your y equals line of your calculator and look at the table of values. But at any rate, 48 breaks down into 16 times 3. And even though there are other perfect squares that go into 48, 16 is the largest. I'm going to go ahead and put a minus sign there and do these both at once. So I have 10 plus and minus 4 root 3 over 6. Now this one actually has to be taken a step further here. I don't know where my pointer went. I'll have to highlight this. The 10, the 4, and the 6 all divide by 2. So we'll cancel or simplify this to 5, 2, and 3. And now we have our final answer of 5 plus and minus 2 root 3 over 3. Okay, this last one here, these last two have negatives under the square root, so it generates the imaginary unit I. So 4 plus and minus I root 36, and root 36 is 6, so this ends up being 4 plus and minus 6i. On the next one, we're going to break apart the 20, but it has a negative in front of it, so we're going to actually introduce the I while we do it. I comes out, and 20 breaks up into the perfect square of 4 times the non-perfect square of 5, and you get 8 there. So that takes us down to 6 plus and minus 2i root 5 over 8. And as long as you can cancel in the triad here, 8, 2, and 6, all three of them, this is the only way you're allowed to do this, cancel by 2 or divide by 2. You get 3 there, 1 there, and a 4 there. So cleaning it up here, we end up with 3 plus and minus I root 5 over 4. And that takes you through the first 6 problems. We'll continue with problem 7 on the subsequent video.